Okay, well, hopefully you had no trouble proving triangles are congruent using the side angle side and the hypotenuse leg theorems, or postulates, whatever they were. Anyhow, we're going to learn a couple new ones today. We'll also learn a different type of proof. It's called a flow proof. So we don't always have to use a two-column proof method. And I think you'll actually like this method. I'll demonstrate it when we get later on in this lesson. So let's take a look. What do we have here? Well, prove triangles are congruent by angle side angle and angle angle side. As was the case yesterday, it is important that we move along the triangle in this order. We come across an angle and then a side and then an angle. And it's kind of like you rotate around the triangle and you go in this order. Same is true for this one. We'll come across an angle first and then another angle and then a side. So if you have a triangle like this, okay, and you have like angle A, B, and C, angle side, maybe you'd start off with an angle here and then an angle here and then a side. So we would prove that this angle is congruent to some other triangle over here, and you'd have like an angle here and then an angle here, and then finally you have a side here. So these work just like yesterday. You just kind of go around the triangle. You come across this angle first right here, okay, and then we're moving along this way and we come across another angle, and because, well, that's for this case here, angle side, notice we ignore, there's no side right here, so we ignore this side right here. We're just looking at the angles as we go around. So we go angle, and then here's the side right here. So there's your angle, and then side. Well, so hopefully you won't find this too confusing. It's the same idea as yesterday. It's just it turns out that there's multiple ways to prove that triangles are congruent, and we will discover today that there's two more methods. Okay, so our objective and essential question: students will be able to prove triangles are congruent by angle side angle and angle side. So if a side of one triangle is congruent to a side of another, what information about the angles would allow you to prove the triangle is congruent? Well, I think you can kind of answer this already. We need to know this pattern right here, angle side angle or angle side. Those kind of tell us what we need to know as far as proving the triangles are congruent. So here's the angle side angle postulate. If you have angle side angle, then we can prove that the triangles are congruent. And once again, I'll just show you the setup. As we kind of move along the triangle this way, and then this way, we come across an angle and a side and an angle. And in this case, the side is supposed to be between the two angles, and in this case it would be what we call the included side, or in this case I like to refer to it as the side in between the two angles. And as long as you have a corresponding triangle that has the same setup, angle side angle, then we can prove that those two triangles are indeed congruent. So pretty easy idea, I hope. Here's another scenario we have. It's called angle side, and notice the setup here. as we go around this triangle here, we come across an angle here, and since we want the angle side set up, we could ignore this side for a second because we don't need the included side. Come up to this angle, and then we come up to the side. And so anyhow, if we have a triangle with the same corresponding parts congruent as the first triangle, then by goodness we can say that the two triangles are congruent. Alright, pretty easy stuff, I hope, but let's go ahead and get started. First thing we want to do is be able to look at the diagrams and determine whether we can use our new theorems or our new postulates, whatever they are. Well, it looks like to me this triangle over here, this one on the left, and then this triangle on the right here, it looks like we could prove that they're congruent by the angle, side, angle, because there's an angle here that's congruent to this angle over here, so that gives us the angle. And then we come across this side here, there's the side, there's the side, and here's the second angle, angle, and angle over here. So we can say that these two triangles are congruent by angle, side, angle. So that would be alright. How about this one? So on this particular problem, it looks like to me the two triangles we're comparing are this one, okay, and this one over here, okay. And if we examine what we have as far as the given information, I have an angle here, and I have an angle here, and then a side. And then over here on this triangle, I have an angle here, and an angle here, and a side. And the question is, okay, so this one matches up with this one, and notice I'm rotating around the triangle this way on the green one, and rotating this way around on the black triangle. But it looks like to me we do have angle, 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 side. We can use that postulate for this particular problem to prove that the triangles are congruent. So yeah, they're congruent by angle, angle, side. Well, so let's continue here. How about this one? Sometimes the diagrams can kind of be tricky because they can overlap a little bit. And what we have in this case are three angles. We have an angle here, an angle here, and an angle here. And then over here we have this angle matches with that angle there, and this angle matches with that one, and this angle matches with this one. But so far the congruence postulates that we've had, we have side, 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 angle, side, and today we have angle, side, angle, and we have angle, angle, side. And if we have right triangles, we have one that's called hypotenuse leg. But in all these cases, you have to have at least one side congruent. And it looks like to me that there's a shared portion from here to here. This is shared by both triangles, but that's not an entire side. And so we cannot say that we have the side in here. We need to get a side in here. It may turn out that this length here might be 6. This length here might be 2, and this length here might be 3. And so now if we looked at the total length here for this triangle from here to here, the total length here would be 9. And the total length from here to here would be 8. And so it could be that these two sides are not congruent, even though they might look like they are. Well, the bottom line is that we don't have any side at all on these two triangles. And so we're missing a side. And so we cannot say that the triangles are congruent based on the angles only. Let me just show you another diagram here that will confirm that. Here's an equilateral triangle. Okay, it's a 60-degree angle here. Okay, here's a 60-degree angle here. Here's a 60-degree angle here. Now, here's another triangle that's equilateral. Okay, in fact, they all three have 60-degree angles in there again. There would be a 60-degree angle here, 60-degree angle here, 60-degree angle here. So these two triangles have the same exact three angles. Are the triangles congruent? Well, obviously they're not. One's way smaller than the other. So angle, angle, angle never works to prove that triangles are congruent. We have to have at least one pair of sides congruent, and then we might have a chance of proving that triangles are congruent. So I hope that makes sense here. Let's go back to the previous slide now. So the bottom line is that we cannot prove that the triangle is congruent because we cannot get another pair of sides in there. So we're going to say no on this one. So there you go. You're going to practice this a little bit on some of your problems. I might add that you have to be careful sometimes. Let me just draw another diagram. You might have a diagram like this, okay, and you might have a side congruent to the side over here, another side over here, and then you might be trying to figure out something. Well, you also might be told that you have parallel lines, okay. Well, in that case, we'd have alternate interior angles congruent. So this angle here would be congruent to this one, and and then you also might have vertical angles congruent. So there's a pair of angles congruent there, and now you could have angle side angle and angle side angle. And so sometimes you have to add in some information from some given knowledge that you have, like if you know lines are parallel, or if you have vertical angles. So sometimes you have to add to the given information. Like on this particular problem, we could have automatically said that this angle is congruent to this one. And so be aware of that as you're working on some problems. So let's move on. So here's a flowchart proof. And it's kind of neat. I want to show you. Whoops, let me back up here. Okay, so a flowchart proof, you can work from left to right, or sometimes you can work from the top and work downward. But the bottom line is that you sort of draw arrows, and like for example, we were given A is congruent to D. Well, that's given. Now, by the way, whenever you're doing a flowchart proof, you have to write the reason underneath this bubble. So every time you draw a little bubble, you have to write the reason underneath. So here we have another piece of given information, and here we have another given piece of information, and the reason is always written underneath. Now, we have these two angles are congruent, and now we want to say that the third angle is congruent. Well, so what we're doing is we're using this information and this information to get this information, you see? And so we put a little bubble here like that, And so the reason that we could say that is the third angles theorem. That theorem said, look, if you have a triangle and you know that the first two angles are congruent, well then automatically the third angle is congruent. And so then what? We also have a side in here. So in this case we have angle, angle, side, and over here we have angle, angle. Oh, excuse me. Back that up a little bit. we have a side. We have angle. So angle, angle, side going this way. We're going around this way. Okay. And this triangle we're going around this way also. So it looks like if we use this angle A and D, C and E, and then we use this side here. So here's our angle, angle, side. So we're going to actually use all three of these pieces of information. Now what we're going to do is we're going to say, alright, now we just showed from this statement that we have this angle here congruent. Okay, so there's an angle here, and here's an angle here. And you'll notice what we have here now is we have angle, side, angle. And over here we have angle, side, angle. Now, it looks like we could have also used angle, angle, side, but in this particular proof here, they did angle, side, angle. So it looks like they're using this information, okay? They're using this information, that's that angle there and this angle here. Angles B and E are this one and this one. And then they use this side. So let's see here. We use this information. Okay. We use that information. And we use this information. You see, so this information gave us an angle. This one gave us the side. And this one gave us the angle. And according to our triangle, if you look up here, we have angle, side, angle, angle, side, angle. And so we can prove the two triangles are congruent by angle, side, angle. So this is what we call flowchart proof. So again, let's summarize the key elements you have. Every time you come up with a statement, you have to write the reason underneath. Reason underneath, reason underneath. And then what you do is you kind of show how pieces are used together. These two pieces were used together to give us that one. And then we had these three all used together to give us this one here. So flowcharts kind of give you a feel how the reasons are connected together. And it's not bad. I mean, you kind of get tired of doing the two-column proof. Let me demonstrate this again with this new problem. Okay, my trash can. So let's try a flowchart proof with this one. In the diagram, AB is perpendicular to BC. AB is perpendicular, so that's that symbol there. Alright, so we have a right triangle. So, and I also have AC is congruent to DF. So, that turns out to be the hypotenuse. So I know there's a hypotenuse here because we have a right triangle. I have a hypotenuse here. Okay. And I know that angle C is congruent to F. Angle C is congruent to F. Well, if I'm trying to prove triangles are congruent, I can use several tools now. I could use side, side, side. You use side, angle, side, which we learned yesterday. Or I could use angle, side, angle. Or I could use angle, angle, side. And also, if we have right triangles, we could use hypotenuse leg. Now, it turns out today, or excuse me, on this particular problem, we could use this one. But keep in mind, we could also use any of these four. Okay? And so if you look at our current setup, if I'm trying to use hypotenuse leg, I do have the right triangles. I do have the hypotenuse but I'm missing a leg. I don't know any of the legs are congruent. So I'm not sure I use this one. But if you take a look here, we do have the angle side set up. I mean, the hypotenuse is a side. So we could think of this as angle, side. We can think of this as angle, side. So it looks like the two triangles are going to be congruent by angle, side. Alright, so now that I have the idea from working from my diagram, I just need to state this in our flowchart proof. And you can do left to right or top to bottom. It really doesn't matter how you do it. I'm going to start off by listing all this given stuff. AB is perpendicular to BC, and I'm going to say that DE, oops, remember what I have to do? I have to write the reasons underneath. So let me put some space in between here. I'm going to put DE is perpendicular to EF. And I'm going to put AC is congruent to DF. That's a D. And then I'm going to put angle, these are segments here. Angle C is congruent to angle F. Now underneath here I'm going to write down the reasons given. Okay, and so there's my little bubble. I have a bubble there, and I have a bubble here. Okay, I have a little bubble here, and a little bubble here. Alright, so underneath these each I need to write down given. I should have used a little bit more space, but I didn't. Given. And this one's given. Alright, so it turns out that these two pieces of information, they give me two pieces of information. Well, how should I write this? Okay, let me see here. Let me back up just a little bit. This piece of information gives me a right angle. So what I would say then is that, well, let me write it out first and then I'll put a bubble around it. Okay, so the fact that I have perpendicular lines here means AB is perpendicular, means this is a right angle here. So angle ABC is a right angle. Okay, so I'm going to put a little bubble there. Okay, now this one, I'm going to put another one. Very similar idea. And by the way, let me erase this so I have some room here. Need some room here. Alright. So, I could say this information gives me angle DA, excuse me. Let me erase this now so I can see these letters. Alright, so DEF, angle DEF is a right angle. So I'm going to put a little bubble around that one. Okay, so remember underneath I need to write down the reason that I could say this. Well, the definition of perpendicular means you have right angles. So the reason that I can do this is definition of perpendicular. And this one also is definition of perpendicular. Okay, so that gives me the right angle, and we know that right angles are congruent, and so I then, what do I want to do? I can then write down this one. This one is going to say angle B is congruent to angle E. Alright, that's this one. And we had a theorem that said all right angles are congruent. So I'll just write that. All right angles are congruent. Okay? So what I have now is that this angle is congruent to this angle. Okay? Now, this angle was given to us, it's congruent. So what I want to do now is use, and I have this side here, I want to use this information, and that information, okay, all three of these pieces of information to give me that the two triangles are congruent. So we'll have a bubble right here, and this is going to say triangle ABC is congruent to triangle DEF. Okay, and the reason that I could say that is angle, side. Okay, you see, so a flowchart proof, remember, you have the bubble and then you have the reasons underneath, and then you kind of show how these bubbles are related to give you new pieces of information. And it's not a bad idea. I mean, it's pretty, it's a little bit less structured, I guess. And so you're welcome to do a flowchart proof at times. And sometimes the assignment will ask you to do that. Okay, so now this shows you the proof. They did it vertically, I think, instead. And well, they did, it's kind of like I did this. They went this way, okay, and then let me see here. Then they went here, okay, and then they used this one, and this one to get the two triangles congruent. So kind of similar to what I did. Alright, so here's a little summary so far what we've been able to do as far as proving triangles are congruent. We could use side, side angle, side, hypotenuse, leg for right triangles only, angle, side, angle, angle, side. And then there's a few that don't work. So the ones that don't work, now let's put a little note here, don't work. Okay, and please memorize this. The ones that don't work, number one, angle, angle, angle. And another one that does not work is side, side, angle. Remember, this one produces two possible triangles. And so we don't know if the triangles are going to be congruent or not. So those are the two that don't work. So that's a little summary of all that we've been able to do. And so on today's assignment, you may have a combination of any of these 5. So good luck on that. So triangles will be congruent if the conditions of angle, angle, side congruence, or the angle, blah, 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 blah. Okay, kind of similar to what we were doing yesterday. But we did learn about a flowchart proof.